What is going on, everyone? Welcome back. In this video I'm going to be showing you what I did inside of Blender to make these clouds look so beautiful. I have combined a few chapters at the end of my cloud simulation course which goes over the lighting, shading and rendering inside of Blender cycles. I included these chapters inside of the VDB asset pack that I just released, and it's been really beneficial to the artists who have been using those. So I just wanted to combine them and publish them here for you. I really hope it's beneficial, and thank you so much for your continued support. Drop a comment below, let me know what you think. I really hope it helps, and enjoy. Welcome back. Here I have a Blender scene open. I am using version 3.6.0, and I'm just going to get rid of the cube and the little light there, and I'm going to hit Shift A and go to Volume, Import Open VDB. Then I'm going to go over to our folder, into Houdini Geo Cache Clouds, and let's import our hero cloud, which is Cumulus Sim 1. And I'll just select the first frame there, click Import, and you'll notice nothing happens, but that's because we are on our first frame of the simulation. So if I go over to this little Data tab, Enable Sequence, there's 600 frames in the simulation, and if we just go to make the end 300, and then let's go to frame 300. You'll see now we have our cloud imported. So I'm going to go over to our camera, click this little camera button here, and then we need to go to this little arrow, go to View, and lock the camera to the viewport. Now we can zoom out, and you'll see we've got some clipping issues. So if I just select the camera, go to this clip start and end, and make this 10,000. Now we can see again. So here's our cloud. Now what we need to do is create an HDRI. So I'm going to go over to my shading tab over here, and let's just go back to our camera. And if we go to our world over there, you'll see that we have this background node, and what we need is an environment texture. So if we go to environment texture and we pipe that in, we can just click open, and again let's go back to our folder here. I'm just going to bookmark this folder, and let's go to our HDRI, and I'm going to go to Table Mountain 1 Pure Sky 4K. Now, if you're wondering which HDRIs we're using, here at Polyhaven, I am using Table Mountain 1 Pure Sky. I'm sure you guys are all familiar with this website, Polyhaven, HDRI Haven. And then the other one I downloaded was Clovendale 48D Partly Cloudy Pure Sky. So these are the two that we will be using. And I've brought in the Table Mountain one. I really like that one, just for look-dimming cloud shaders. And then what we are also going to need is a mapping node. We'll plug that in. And then we need texture coordinates. So texture coordinates, and we'll plug the generated ones in there. So pretty sure we can view our Table Mountain, and if we just click Z and then go up to rendered, we can have a look. So let's go back over to our camera, and you'll see that we don't see anything, and that's because we do not have a shader on our object. So I'm just going to click New, and so nothing is happening here. So let's check out our render globals, and it's currently set to Eevee. So what we want to do is go to cycles, and now we have something here. So I am going to switch this over to GPU because we like that GPU. And let's update our render globals here a little bit so that we can get ready to start shading our cloud. And for viewport, I'm actually going to bring these down. I'm just going to do 256 for now. Our max samples for our render, I'll just do 1024. These are pretty low settings. Just for now, we will crank up our final render ones. Now, what we need to do is come over to our light path max bounces, and you see volume is set to 0. So I'm going to crank that up, and as I start to increase this, you'll notice that our cloud will start to get brighter. And that's because we are now allowing light rays to enter the volume, bounce around, scatter, and then either leave or basically die. So I'm going to crank this up to 32 and 32. Now keep in mind that this is where a lot of the magic happens, and this is also where a lot of the render time goes to, because the more bounces that you allow within your cloud, the longer it's going to take to calculate. That's why I love working on GPU, because it is a lot faster than CPU, and I've got a machine that is built for this sort of thing. And ultimately, we want to give clouds as much scattering like abilities as possible. So the higher you can kind of keep these numbers, the better your clouds are going to look, because that is what is happening in real life. Light is entering the cloud, scanning around, and bouncing out, except we do not have a computer that is doing that. It's just all happening naturally. So with our volume bounces set to 32, I'm also going to crank up our transmission bounces, our transparency, and you'll see that our total is set to 32, but these bounces kind of stack on top of each other. So I'm going to give this 4 more just to account for the diffuse and glossy bounces, even though we probably won't need this. I just want to make sure that our bases are covered here. And I just want you guys to notice that in color management, I am using ACES because my workflow is ACES CG. And if you don't have ACES installed, it's not really important. You can still use Filmic or whatever Blender ships with, but for my compositing programs, I have an ACES workflow, and that is for Nuke and After Effects. So I just wanted to point that out. The rest of the settings here, we should be okay for now. We might come back in and change a few things, especially when it comes to final rendering. But now that we have our cloud, and we've set up some basic render settings, and we gave it just a basic shader. Now what we're going to do is we are going to create our own custom cloud shader. So I'll see you in the next chapter. In this chapter, we're going to be building our cloud shader. But before we do that, I just wanted to give a huge shout out to my man Samuel Krug over here. Please check out his YouTube. He's also got a Discord. There's loads of awesome conversations happening in there. He put out this tutorial a couple months ago called 3 Minutes to Perfect Clouds, which is essentially what we are going to be building here today. But Samuel has had a huge impact on my development and pushing our clouds to the next level, opening up my eyes to Blender, and it's just been really great to connect with him and the people in his community. So go check him out. I just wanted to give a huge thanks to him because without him, I would not even be using Blender, and I would still be using Redshift. And for anyone who's interested or wondering why I'm using Blender, to be honest, this shading network has the most control that I've personally used, and Blender is obviously free. Cycle's GPU is super fast, so in the coming months, I'll probably play around with Karma again. I started using like Karma and Solaris inside of Houdini a while back, when it maybe like over a year ago. The tool just isn't quite there yet. I know that there are a bunch of awesome updates, so I'll have to play around with it soon. But we are using Blender for this, and I have been loving it. So to jump into our shader, I'm just going to delete this principal volume, and let's throw down a volume scatter. And let's plug that in. And then we also need some attributes. And that will be density, because we want to read the attribute on our volume, and that attribute is density. And we will plug that into our density here. But so we get something. But now this is essentially just reading it as default. So what we want to do is modulate our density based off of the ray depth. And to do that, we will need a light path. And you can see that we've got our little ray depth down here. So now we need to use some math to modulate the density based on our ray depth. So I'm going to throw down a math node. We'll set this to power. I'm going to grab our ray depth and plug it into the exponent. And then I'm going to Shift D to duplicate. Grab the ray depth as well. Plug that into the exponent. I'm going to set this to about 0.9. We'll set this one to, we'll just leave this one at 0.5 for now. And then I need another math node, so I'm going to duplicate, and we'll set this to add, and we'll set that to 1. Now, this is going to be our anisotropy over here. So we'll plug that in. And then we need another math node. So I'm going to duplicate this one. We'll set this one to multiply, and we'll duplicate this again. Keep it at multiply. Let's pump our value up to say 10. This is now our density. This is where our density is going to be read from. So it's got a value of 10. And then I'm just going to plug this in for now. And we will multiply our density there. And this is essentially the basic shader setup. So I'm going to go ahead and click Z, and let's render and see what we get. So there we go. Our cloud is already starting to take shape, and it's looking pretty good. Again, this takes a bit of time, so what I'm going to do is go over to our render settings, and let's come down to our step rate. I'm going to increase the step rate to about 3, which should speed things up a bit and not lose too much detail. And just for the sake of it, for speed, I'm going to keep this at 3 as well. That's for our final render. And let's go ahead, and I'm just going to duplicate our volume scatter. We'll plug in our density, and then I'm going to just plug this straight in so you can see the comparison. So this is what the kind of default looks like. And again, we don't have any anisotropy, so I'll set that to 0.8. But you can see that it is still pretty dark in spaces, and comparing to our current setup is that this looks a lot nicer. So this is the basic setup. Now, just to make things a little bit nicer for you guys, let's take this one step further, and we can eke out a little bit more control and just make it a bit nicer to work with. So to do that, I'm just going to get rid of this, and what we need to do is we need to make this into a group. So I'm going to select all of these, and I'm going to right click and say make group, or you can hit Control G. So there we go, we are inside of a group now. If we click this little up arrow, you'll see that we have this group, and it doesn't have a lot of inputs, and it's connected to our volume. It looks pretty much the same. If we click on this little icon on the node group, we can jump inside. You'll notice that we have a group input and a group output. And now let's make some controls so that when we make adjustments, we can do that with a little bit more ease. So I'm just gonna stop the render. We'll leave that like that. And let's go to our group input, and let's add some inputs to this. So if we click on our group tab, you can see inputs and outputs. So for our group inputs, what we want to do is we want to add an input, and we'll go to the name and we'll say density value. Let's put the default at 1, and let's create a new, and let's call this density gamma. Put the default at 1 as well, and then let's create another one. We'll call this one density fall off, and we'll make this default, let's say 0.3. And let's create another one, call this anisotropy. Let's put the default to 0.9. And then one last one, let's call this anisotropy fall off. And let's set that default to 0.5. Cool. And I'm just going back because for some reason this has changed. So there we go. So now we have some controls here. If we go back, you can see that we have our control values here, and didn't give us our defaults. So I'm just going to set the density to 1. Actually, it's 10 on the inside, so let's do 10. Density gamma, we can keep it 1. Density fall off, let's do 0.3. Anisotropy 0.9, and anisotropy fall off 0.5. Cool. So where does this all plug in? So our density value gets plugged into this value here. It's just going to overtake that value of 10. For our density gamma, this kind of helps control how dark our shadows kind of get inside of the cloud. I'll show you it as we start rendering, but what we need to set that up is we need another math node, which I'm just going to hit Shift D and duplicate here. And then we're going to change this to power, and the exponent is going to be our density gamma, just like that. So let's keep this like this and like this. Now our density fall off, what we are going to do is we're going to multiply our ray depth, and we need a multiply, and that is going to go to the fall off. And then our anisotropy, this is essentially just the value of our anisotropy. So that's going to be plugged into our base over here. And then in order to get some fall off of our anisotropy, we need to now multiply. So I'm just going to shift D, duplicate. This, we need to multiply this value to get some fall off. Just like that. So now we have a pretty nice cloud shader to kind of play around with. If we jump up to the top level, we can now play around with these values pretty easily. And if we hit Z and then go to rendered, now we are starting to get some really good looking results. And let's do a couple of renders to really check out our details. So I'm just going to tumble around here. You can see that we're starting to get some really nice surface detail. So we can start slamming these values around, increasing our density, playing around with the gamma. Now the gamma, like I mentioned, is going to be controlling the shadows of our cloud. So if we actually take a look, let's bring our gamma down, maybe gamma up. So there, you can see that we're starting to really tighten the how our shadows and our fall off works respectively. So it's nice when you have like a lot of density in your cloud inherently, and you start getting these darker kind of pockets, which we don't really want. I think even if we lower our density, you can see that we still get some really dense shadow pockets over here. If we lower our gamma, it starts to flatten that out and basically helps to control those areas where the light is just kind of getting trapped. So even now, right here, with our kind of defaults that we set up, we are getting some really nice results. And these are pretty much the values that I play around with. So it's a very good base to kind of start. And for now, I'm going to call that done on our cloud shader. Let's do some nice hero renders, and I'll show you how to set these up to export our render layers, our AOVs, so that we can have a little bit of control in post, and then we'll take it from there to get our final images. So I will see you guys in the next chapter. Let's play around with some cameras.